Name the gas that is produced in each of the following cases. First, sulfur is oxidized by Kong nitrate acid, so NO2, nitrogen dioxide. Then iron 2 sulfide is treated with dilute sulfuric acid, hydrogen sulfide H2S. Then cold and dilute nitric acid is added to copper. Gas releases nitric oxide NO. Then add anode during the electrolysis of acidified water, oxygen. Then magnesium is treated with dilute HCl. I have written hydrogen H2.
For the A part, you got like, is SO2 also correct? Like
SO2, no.
From H2SO4, no?
Yeah. Okay.
Which question?
The first.
Once again, I'll repeat all in the order. First is nitrogen sulfide NO2. Second, hydrogen sulfide H2S. Third, nitric oxide NO. Fourth, oxygen. And fifth, hydrogen.
Nitric oxide, you can write it as nitrogen monoxide, right?
You can write it as nitrogen monoxide also. The first one is hydrogen chloride gas. The second one is chlorine gas. The third is ethane or acetylene. The fourth is ammonia. And the fifth one I didn't actually get because I think I forgot this. So
will it be?
I wrote cesium.
Yeah.
What is the
francium?
Francium is radioactive.
That is radioactive.
Right? Yeah. But it's still the most metallic because it's at the bottom.
Yeah.
But in the textbook, like they have given like cesium because francium is like radioactive.
Yeah, that's what they wrote.
Also, cesium is the answer.
What did Jendra say? What is the reason for not considering francium?
Because francium is radioactive, so we don't fully know all the properties yet. That's what they wrote in the textbook.
In the textbook, like in the box bracket, it is there. So.
Yeah.
What is the answer of the third one?
Ethine.
Choose the correct answer from the options given. First one, a chloride which forms a precipitate that is soluble in excess of ammonium hydroxide, CuCl2, that is copper chloride, fourth option. Second, if the molecular formula of an organic compound is C10H18, it is third alkyne. Third one, which of the following is a common characteristic of a covalent compound? Second, consists of molecules. Fourth, to increase the pH value of a neutral solution, we should 3. Add an alkali. Fifth, a drying agent used in the lab preparation of ammonia. 3. CaO.
Yeah, the first one is catalytic oxidation of ammonia. That's 4NH3 plus 5O2 with PTA and 800 degrees Celsius gives 4NO plus 6H2O. Second one, action of heat on the mixture of ammonium chloride and sulfide. 2 NH plus Cl plus CaOH whole twice to give CaCl2 plus 2 NH3 plus 2 H2O. Then reaction of anode during the electrolysis of acidified Cs. I don't know if it was with like the platinum ones or the copper electrodes. So I know Cu minus to me they give CO2.
No, but I think the question is wrong. What do they mean by acidified CuSO4?
No, acidified is in electrorefining. You have to write the one of electrorefining.
Okay.
For the if you consider the anode to be of carbon.
No, in electrorefining, the anode is an impure block of copper and the cathode is pure.
Isn't it acidified even in normal case to prevent electrolysis or something?
Yeah.
No, but in the textbook it is acidified only in electrorefining.
So what is the answer? The active one, right? Like we consider it the active reaction.
Yeah.
Shouldn't it be aqueous CuSO4?
Yeah, it's aqueous CuSO4 in other cases, but it is acidified in electrorefining.
A salt cannot be acidified.
But I feel like they add traces of dilute sulfuric acid to better the dissociation. Like I read that somewhere.
But that's for water.
I'm not sure, but okay, fine. So it's the active reaction, right?
As for me, both should be like allowed because even in that one,
they haven't specified.
No, but it's acidified in both cases. Otherwise, it forms like the precipitate of COH twice, and the reaction won't take place.
Yeah, but in the textbook they have only mentioned in electrorefining.
No, they have. If you go to page 117, there's a give reason on the top that says the electrolyte aqueous copper 2 sulfate may be acidified with traces of dilute sulfuric acid.
So I think both will be accepted.
Yeah.
Because like eventually the process taking place is the same, right? It's just been given different names, so nothing different is happening in either of them.
So it's Cu minus 2 electrons gives Cu2 plus, right? Yeah.
And even the second one, that OH1.
Oh, okay.
I think if they wanted specifically the copper one, then they would have specified active electrodes. So I guess both are accepted.
Yeah, I think both should be there. Fourth one, action of concentrated sulfuric action on cane sugar. So that's C12H22O11 with concentrated sulfuric acid gives 12C plus 11H2O. Fifth one, reaction of an oxide of a trivalent metal with hot concentrated sodium hydroxide. I wasn't sure of this answer, but I wrote Al2O3.2H2O plus 2 NaOH gives 2 NaLO2 plus 3H.
Do we need to? Will it be only Al2O 3.2H2O, or like do we need to only do the oxide? Like when I wasn't sure of this one.
Even I wasn't sure.
But then it can't
I
be
wrote-
bauxite
I just
because
read
it's
it,
not
I
written bauxite.
I
Is it
think
the
the
aluminum
aluminum
oxide one?
They didn't say it's a hydrated oxide. It's just they just
Yeah.
said oxide.
Yeah, but either way, you get the same products.
The balancing differs.
Yeah, the
Yeah.
balance.
Yeah,
It's
H2O
the same
becomes
products. If you take hydrated, you'll get aluminium, sodium aluminate for that Bayer's process. And if you take oxide, you'll get sodium oxide as a product.
Okay, so it differs.
So we do the non-hydrated form, right?
Yeah,
So different balancing.
yeah.
So wait, what's the right answer? The hydrated one or the other normal one?
Normal no. Because they haven't mentioned hydrate.
Cool. Then Natasha, you
Is the
can read.
non-hydrated reaction there in the textbook?
Non-hydrated one. It's in the first 3 chapters, I guess. One chapter in that. In the salt.
Don't you get illuminate in both cases?
You get aluminate and water in both cases.
Right?
Balancing is different, no?
Only H2O, like without the hydrated, it's H2O, and with the hydrated, it's 3H2O.
Yeah.
The give reason.
Yeah.
So the first is the concentration of the electrolyte does not decrease during the electrorefining of metal. So electrorefining is the process of removing impurities from an impure metal electrolytically to obtain a highly pure metal. The anode is the impure block of metal and cathode is the pure thin sheet of metal. For every ion that is discharged at the cathode, a neutral atom is added to the solution by the anode. Hence, the electrolytic levels. The second one is hydrogen molecule has a single covalent bond. Hydrogen has one valence electron in its electronic shell. Therefore, to become stable by duplet electron, it needs one more. By duplet configuration, it needs one more electron, and hence it shares it with another hydrogen atom, forming a single covalent bond. The third one, atomic size decreases across a period but increases down a group. So the atomic size depends on the number of electron shell and the nuclear force of attraction. In a period, as we move across from left to right, with increase in atomic number from left to right, electrons are added to the same valence shell and no new electron shell is added. But at the same time, the nuclear charge increases constant. With increase in the atomic number, with increase in the atomic number, it pulls the number of electron shells more strongly towards the nucleus, which which results in the decrease of the atomic size. Whereas by moving in a group from top to bottom, atomic size increases as the atomic number with increase in the atomic number, new shells of electron are added, which overcomes the nuclear force of attraction, hence it is increased. Then, concentrated solution of alkyl. Al2O3 being amphoteric in nature dissolves in caustic alkali, forming soluble sodium aluminate, whereas Fe2O3 and SiO2 remain unaffected as insoluble impurities and are filtered out. The last one, dilute nitric acid is stronger than concentrated nitric acid. So nitric acid decomposes to give nascent oxygen, which oxidizes metals, nonmetals, and compounds, and thus it is a powerful oxidizing agent. Concentrated nitric acid on decomposition gives only one nascent oxygen, whereas dilute nitric acid gives 3 nascent oxygen. Hence, it is more strong.
I think I wrote a different answer. For
Even for the last one, I wrote a
My
different
third
answer.
and fourth one is different. And fifth one. Same.
I wrote that it yields a high concentration of H plus ions in dilute and low in concentration.
Even I wrote
There are
that.
no free ions because it's covalent, but then they are formed in aqueous solution because it is a polar covalent compound. So that's why it's more of an acid. I didn't get the fourth one though.
Yeah, just to
Concentrated
what
alkali.
I think what Mishti said was right for that to filter out these.
Yeah, the amphoteric thing.
Yeah.
So the answer was filtering out the
Impurity.
yeah.
What's the fifth one though?
I said dilute nitric acid contains a larger percent of solvent molecules to interact and form hydronium ions in comparison to concentrated nitric acid having a larger percentage of acid molecules. Therefore, dilute nitric acid is stronger than concentrated nitric acid.
Okay, cool. Thanks.
You all wrote the same thing, right? Or something similar to this.
I wrote like everything that it has like the higher concentration, but I didn't mention ionization and everything. I just wrote there was higher concentration in aqueous
Yeah,
solution.
Even I wrote that.
And then I also wrote that there's complete disassociation in case of dilute, and that doesn't happen in concentrated.
Yeah, but for the reason, why is it concentrated solution? That's what they're asking, right? If the alkali is being used, why is it a concentrated solution?
No, but that depends on which part you're focusing on. Like if you say alkali part, and like if it's amphoteric, then that is to filter it out. But if you focus on concentrated, then there's no actual reason for that.
But how would you know what you're writing for? Or what they're asking?
Because you know that it's
Given in
amphoteric.
the textbook, like word to word. I think we'll just copy that then.
Yeah,
What was
the
given in the textbook?
Where is
Yeah.
it? It's a
It's a
reason
metal
for
It's
the
there on the page of
Amphoteric,
Beer's
right? And all the impurities.
When they mention the impurity, then they say like
Yeah, all that.
Silica and iron oxide. They are non-amphoteric. We don't create.
Riya,
What was the answer?
I got the answer is FeSO4.7H2.
ZnSO4.
Yeah, ZnSO4.
Is there any way we're supposed to clarify what we are taking as the water molecules and like whatever oxygen is left just goes away? Like
Yeah.
Yeah.
It's like part of
So 7 goes there, that's why 4 is left.
but
Yeah.
can we clarify that like how we did that, or can we just write it I don't directly? think so. I don't think
They
it's
have
that
given
way to store
in
it.
water of
I wrote it in just one line, like
Just like give a
basic
yeah, one line exactly.
What was the oxygen ka simplest ratio?
I got
11.
11.
yeah 11.
It should come to
And then for H, what did you guys get?
14.
14.
14, yeah.
so like
So it's 1, 1, 11, 14, right?
Yeah. 1.
Yeah.
And then EF, what is EF? Wait, I got 278.
Yeah, 270.
287.
287.
Yeah.
287.
And then it cancels in empirical as equal.
I'll just check.
in the
So
relative
first
number
step
of
is you're
atoms.
dividing the percentage by the molecular weight, right?
Atomic, yeah.
Yeah. What did you what atomic weight did you write for oxygen and hydrogen?
They gave it now 16 and 1.
Yeah, but like sometimes you use 32 or something like that, right?
That's for
No,
sulfur.
32 is for O2. Like if they say it's molecular oxygen, then 1602.
Oh, okay, that's right.
In the the fourth column, the relative number of atoms, what did you get? Like 0.3 or something? Or
Yeah, 0.34.
Yeah.
Yeah,
0.34. Yeah.
okay, so 2 decimals, right?
I took,
I
but it's not necessary because you're anyways doing approximation.
like I didn't only the first decimal and I got it wrong. Like I got 12 over there then. So I guess.
No, I think you should take 2 decimals.
Yeah, I did.
Even if we take 2 decimals, it still comes to like decimal is the
Yeah.
simplest ratio, and then you approximate it, right?
See, it came to like 11.01. So
Yeah,
it would
it
have
came to
anyways.
11.26.
No, I
That's
didn't solve
11.2.
it only that. I just left it at 11 and something, and then I rounded it off 11 only.
But if you get 11.26, can you directly write 11 in the simplest ratio?
Yeah, you're supposed to write 11 only.
Yeah.
In the text.
Only if it's greater than 0.5, then it comes there.
Also 14.566 I got.
I got 14.35.
I got
Again
14 points.
calculation.
In the textbook for the sums, instead of taking approximation, they multiplied by the least number till which they can get a whole number.
Yeah, but see, you can
That's
only do
so
that
low.
if it's like 1.5 now. If it's more than that, then it becomes difficult.
Then you just take the closest number.
So if it's a smaller number, you multiply all the simplest ratios, and if it's a bigger number, you just approx, right? Because
Yeah.
Yeah.
If it's 14.02, then you take it as 14 like that.
Okay, next question.
Yeah, you can do that.
Yeah. E. Give the IUPAC name of the following organic compounds. First one was 2-methyl-butanal. Second one was 2-methyl-2-bromopropane. Third one was
Do you write bromo first or
Yeah, it should be.
No,
Not
bromo.
bromo.
Yeah.
what was it?
2-methyl.
Yeah, alphabetic. Third one is 3-methyl-2-butanol.
Yeah.
Third one is state the type of isomerism in the following organic compounds. First one will be position isomerism, and second one is chain isomerism. I didn't understand this question like at all.
But
What was the third
I think-
IUPAC?
Like, do we have types of isomerism to begin with?
We have
Yeah,
We can chain
it's
and
not
position.
complicated, just 3 things.
Can someone please repeat the IUPAC name?
First one is 2-methyl-butanal. Second one is 2-bromo-2-methylpropane. Third one is 3-methyl-2-butanol.
You can also write it as butan-2- already.
Yeah.
Yeah.
The F part I
How did you
wasn't
get the
getting.
third one?
Third one.
The IUPAC
Because
one.
you start from the side which is closer to the functional group.
Yeah, so it will be 1,3 methyl now.
Why? By 1,3.
Sorry, 1,2.
The longest chain.
the longest chain is 4, so you don't need 2 methyl groups.
Okay. So only 2 methyl. No.
No, just one.
Three
That's 3-methyl.
3 methyl butane.
Butan.
As long as
it's not.
as the hydroxyl has 2, you can do whichever way you want. Like you could branch it out or take the straight chain over there.
And are we supposed to write butane to all?
You can
I
write
know.
you can all
do that,
have
I think you have to clarify whatever's placing is in 1, right? Otherwise,
Yeah, you don't have to mention one, but otherwise you have to write.
We only don't have to mention in aldehydes and acids
And-
because
yeah,
it's
Yeah,
done by
because
default.
always
Yeah, because it's always the first.
even if it's first you mention for alcohol, right?
Either way is
Yeah.
okay.
No, it doesn't matter if it's first, but if it's not first, then you mention.
Okay.
If it's first, it's okay if you mentioned, right? Like marks won't be cut off.
Yeah. Also, guys, it's a pretty lame question, but in our textbook, whenever there's naming of IUPAC, the first letter is always small caps. Manila Miss always says capital. So which one do we do? Like for the first
Capital.
One cap for the parts.
But board mein milega na. I mean, it's not such a big deal, but
Yeah, I think
I think it's supposed to be
she's like
capital.
she's just focused on all the higher kind of organic chemistry, but because it's very basic level for 10, they won't look at all the capitalization and all that.
okay.
Neelam is one.
I think they'll accept it both ways, but it's better to do the cap thing, like capital.
Mm-hmm. Cool.
And like in alcohol and bromine, like which has the priority? Like
Alcohol.
Is there any priority list?
Yeah, there is.
There is.
Yeah. See, then double bond, triple bond, and then substitute.
Yeah. Functional group always comes first, no matter what. But I think if it's double, triple, then like you give preference to that.
No, I'm pretty sure it's functional groups first, and then if there's double bond, triple bond, and then uske baad substitute.
No,
I'm pretty sure that's right.
with the double bond.
No.
So alcohol
Does
is
bond get preference or the functional group?
I'm pretty sure bond gets preference.
It's functional.
Yeah, like if it's like a ketone or it's a carboxylic acid, then that's always
See,
first.
But
then-
that is anyways the first to make. It's not possible
Yeah.
that a carboxylic acid is not first.
Yeah. So, but even if it's a ketone gets least number.
Ketone
And then
hai.
after that, and then after that it is the double and
Even we
triple
don't
bond, and then
have
after
double
that.
functional group anyway, so it does not matter.
Yeah,
Like what function.
No, see, other than in aldehyde and in carboxylic acid, it's always first. So that's wo ho jata hai. But in other ones where it's alcohol or if it's something else, some other functional group, then the bond gets first priority and then the functional group.
Yeah, like I think you
Guys,
always
I'm
give priority
pretty
to the
sure
double,
it's
triple.
functional group first.
I feel like double, triple tops that.
Double triple first.
Yeah. It's a functional group,
The
then
bond
double
plus
triple,
that.
and then that other one.
Yeah. Okay, fine. We can you all Google if you can? Because I mean,
But it makes
Google saying
sense.
functional group.
Yeah,
yeah,
according to
it's
saying
always
functional group.
functional group, then double, triple, and then subs.
I'm just looking at the possibility.
but like we don't have like double bond and like a functional group. So
Yeah,
We won't
I
have
don't
it
think
for
so.
both, but prelims we might.
I don't think prelims also we'll have. They're gonna give easy papers because it's offline first of all, and then like it's prelims. It's kind
But
of covered.
Neelam gives to horrible papers. She gave esters and ethos and all that shit.
I don't
but I
think
think this time she'll stick to the portion. I feel this
I
time.
are gonna study the mole outer portion thing which she told us to study.
I'm just going to read through it. That's it.
No, because it's too much.
unnecessary. So annoying.
But guys, there's just like one formula for all of that. I know she does the crisscross thing, but there's only one formula, which is the number of moles, and then you equate that to everything.
but she can't give that
Yeah,
like
okay,
in a
fine.
question.
Yeah, she can't give it, so it's okay.
Okay, who can do F? Because I didn't get F at all.
Can I do F?
Yeah, do F.
Yeah.
Okay, so hydrogen, firstly, just let me read the question. Okay, the following statements are only under certain conditions. Rewrite each statement, include appropriate conditions underlined in your answer. Firstly, hydrogen chloride gas is an electrovalent compound. Hydrogen chloride gas ionizes when dissolved in water and displays properties of an electrovalent compound. It behaves as an electrolyte.
Can
Yeah,
we
but
change the
that's-
sentence that much?
Is
I
that
don't
yeah?
think
Can't
You just have to add like
Just have to
the
add
or
Ah,
something.
okay. Oh,
I just
that-
wrote hydrogen
What's the
chloride
answer?
aqueous solution.
Same. I wrote the same.
I wrote
What did
end
he
में
write?
I just wrote hydrogen chloride acid / aqueous solution because acid and aqueous solution are the same.
Oh, okay, that way. Okay, fine. I mean, I wrote it like explanation. Okay, fine.
Like I wrote at the end like in water, like electrovalent compound in water.
Okay, fine. So then, second one, ammonia turns red litmus blue. Liquor ammonia turns red litmus blue.
I
That
just
okay?
ammonia turns moist.
Even I added moist.
But then,
I
like,
think you just need water somewhere to like ionize ammonia.
To ionize and get ammonium hydroxide.
so liquor ammonia is ammonium hydroxide.
I think even if you write aqueous solution of ammonia, I guess it's fine. Yeah, like it's the same thing.
Okay, concentrated. Okay, sorry. Sulfuric acid is the least volatile acid. Concentrated sulfuric acid is the least volatile acid. Fourth one, hydrogen chloride is soluble in water. I don't know what this is. Like, what's the
highly soluble.
Hydrogen chloride gas.
Highly.
Hydrogen chloride gas is highly soluble.
Yeah, I wrote hydrogen chloride gas is highly soluble in water.
But how is that the condition?
Exactly.
Because
Gas is the condition.
But if it's
gas is a condition.
But if it's acid, they would have said hydrochloric acid.
yeah,
So I think it's already
If
implied.
hydrogen chloride is already in the form of an acid, it's already in water.
Exactly.
yeah. But then there's nothing left, right?
But
Highly
highly,
soluble.
We've written
No.
both.
Yeah, I wrote highly soluble also.
but highly isn't a condition, right? Highly is like,
Exactly, it's soluble either way.
So then
I
what's
think it
the
would have been
answer?
gas, honestly.
But it doesn't exist in any other form. Like it's not a solid. It only exists in gas or like acid.
dumb question if you ask me. Like, what the hell?
Yeah. I think it's gas then that way. Or they would accept like gas and highly soluble.
Yeah. Okay, fine. Fifth one, lead bromide decomposes electrolytically and gives bromine gas at the anode. Molten lead bromide. Yeah.
Do we need to mention the temperature as a condition?
No,
No.
I don't even remember it.
Yeah,
so I
what is
didn't
the temperature?
280 degree.
I thought it was 380. I think 380.
yeah.
Yeah, 380.
So question 2 now. Where were we? Like, anyone wants to do like?
Can I do it?
Okay. Oh, I guess we were at like Ria and then Roshni did one. You can do it. Yeah. Natasha and then we can start with Sana.
Okay. Question 2A1 was the question. Match the atomic number 2, 4, 8, 15 and 19 which is following. I got 15, 19, 8, 4 and 2. Is that correct?
Yeah.
I got the same.
Wait, can you repeat it?
15, 19, 8, 4 and then 2.
Okay, the fourth one, can't it be both 8 and 4?
No, but it
Because
would be
it's the one.
then there'll be like 2, 4.
You can't repeat two.
But then, yeah.
But 8 isn't
One second, how is 8 in group
It's
2?
group
Yeah.
period.
8 is not in
gonna be-
group 2.
Yeah, and third is going to be fourth, and then fourth will be. Right?
A gaseous element with valence
is 8.
See, gaseous, 8 will be oxygen, right?
Yeah,
it's
8 is
gaseous
oxygen.
and its valency is -2. It didn't say it's in group 2, it said its valency is 2. But it would be in group 6, right?
Yeah.
Guys, how is the third one 8? Because gaseous element with valency 2. Can't that be 4?
It can be.
Array 4 is beryllium.
Valency 2 meaning -2.
Beryllium isn't a gas.
Yeah. When its atomic number is 4, its electronic configuration is 2, 2. So it's like it's a metal and it's like a solid, I think.
But it's a gas.
No. But then 4 will get repeated and it's matched the following now. So
Array, but 4th is beryllium anyways. It is a solid.
It's solid.
Fourth, is beryllium a gas? I don't think so, right?
No, it's a solid.
An element belong to.
It just says element. I think it can be 4 only.
Yeah, rare gas is obviously helium.
Yeah.
You have to get 2.
So third one is what, 8 or 4?
8.
8.
B. State your observation when excess of ammonium hydroxide is added to the salt solution of lead carbonate. We can write. Can we write carbon dioxide released?
one.
Lime water milky and has no effect on pink acidified KMNO4.
No, that doesn't happen. That's chalky white.
Yeah, I wrote chalky.
Chalky white.
I wrote chalky white precipitate here. And
It will be insoluble. It'll be insoluble.
yeah, insoluble. Yeah.
You can't write the carbon dioxide thing now because it's not an acid.
What are you talking about?
Yeah, the reaction doesn't release CO2.
You cannot write
It doesn't release CO2 now.
exactly because it's not an acid.
Yeah. Okay, second one, zinc granules added to the solution of iron sulfate. I wrote grey iron is deposited.
Same. And I wrote colorless solution of zinc sulfate is obtained.
Yeah.
Is this anywhere in the text?
In the GP.
Where is it in the textbook?
It's not in the textbook.
I wrote
I
that
wrote the color
But
changes
it's
from
always like if
It usually comes as hydrogen becomes liberated and then you do a test for that.
Yeah, but we can also write with the green color the solution disappears, right?
Yeah,
I'll
green
Google
solution
it.
becomes colorless and a gray precipitate is deposited.
But where's this from? Like, how do you?
I got it from Google.
Like if you just do the reaction, then it's like FeSO4 is changing to ZnSO4 and Fe thingy was green, so when this thingy will be green. Like I just did that.
Yeah.
So what did you write? Like you wrote green.
Green solution becomes colorless.
Okay. Third one, dilute sulfuric acid is added to sodium carbonate. Carbon dioxide released. Lime water turned to milky has no effect on pink KMNO4. Then fifth one, fourth one, ammonium is passed over an amphoteric oxide. I have no idea what this is. I think water is formed with salt and water.
I wrote white ammonium salt and water.
Yeah. And I gave a test for water. Just
Yeah.
at
But like, what test you give for nitrogen? I mean, we don't know anything.
Colorless, odorless gas which doesn't rekindle a glowing splinter.
or we can say that
Or like lime water milky thing.
but ammonium salt is formed now. What like how is
How will
nitrogen?
ammonium be formed?
Which one
See,
are you
now,
talking about?
if it's amphoteric and ammonia is there, so then the amphoteric thing will act as an acid. So then acid
Yeah.
plus gives
So water plus acid is formed, right?
but the only
No.
but the only
I guess
reaction there
ammonia
is
will oxidize the.
It is salt
Yeah,
and
it
water.
should be
Salt
reduced.
and water will be formed.
Salt and water.
Are they know in the textbook this reaction is there now, that buff yellow?
Yeah, the buff yellow thing. Even I wrote about
It
that.
turns to silvery lead, right? The yellow color
Yeah,
thing.
the Irish method. Yeah.
So it will become aluminium.
Huh?
No,
So the
I
final.
wrote the reaction in terms of PB because PB is the yellow thing.
Exactly. I wrote in.
Yeah, so nitrogen will be liberated, right?
Yeah. With
That's
Yeah.
the only
Yeah,
answer.
Nitrogen and water and then
and with oxygen this gas turns reddish brown. And
but we don't really know if aluminium is liberated because both copper and PB have valency 2 now. This has valency 3.
Oh, so you're considered an amphoteric oxide.
Yeah, like.
Like from
Yeah,
the
neither. Wait, if I don't think PB is amphoteric, is it?
It is.
It's-
PB
it is.
Z and PB AR.
Zn is amphoteric. Yeah.
So the
Okay, so
final
but then,
answer is
like,
that
what's wrong
nitrogen
with
is liberated, right? That's the
Yeah, nitrogen and water vapor.
okay.
Fifth one, ammonium chloride crystals are heated strongly in a dry test tube, dense white fumes.
Guys, I'm
If you
sorry.
write the
Can someone
product,
explain how we got
everything is
nitrogen in the fourth one?
so
That test is then to show ammonia as a strong reducing agent. So
Huh.
the above yellow lead oxide, you react with ammonia, it becomes lead, then nitrogen and water is released. Similarly, for copper oxide, that black copper oxide becomes brownish pink copper metal and nitrogen released. So in terms of that, we're writing for aluminium oxide. because it's not given anywhere in the textbook.
Oh, okay, cool.
For the last one,
Sana, it's on page 174, or there's an equation. Refer to that if first.
for the last one, do we also add that nothing is left in the test tube, like sublimate?
Yeah.
I guess I understand.
Do we have to write crystals directly change into gas?
I mean, you don't have to write it becomes liquid, just write dense.
I think we have to say dense white fumes are formed which remain suspended in the air, because I remember reading the statement somewhere.
Yeah, that is.
Okay.
Should we write like the particles of NH4Cl condense on the cool parts of the test tube? White solid particles.
I don't think that's necessary.
Here we don't know like it is burning in a test tube or like any other open jar or something.
When it's heated strongly, won't it form the individual gases?
That's what I wrote.
They haven't specified the temperature, and it's like 500 degrees Celsius. So
No,
about 500.
I wrote about the individual gases.
Even I wrote about the strongly.
yeah, but you can
So I thought it decomposes.
you can also mention that there's a pungent smelling gas or odor released.
But which one is correct? Dense white fumes or the separate observations for both the gases?
No, I
But
think
it wouldn't make sense now. It wouldn't make sense. First it sublimates to give you vapors, and then suddenly those vapors are gonna go out of the test tube. Now you're not further heating those vapors to make them solid. They'll remain suspended in the air, I think.
Google says ammonium chloride appears to sublime upon heating but actually decomposes into ammonia and hydrogen chloride gas. Ammonium chloride reacts with a very strong base like sodium hydroxide, blah blah blah. But it says it decomposes.
So I think what we can write is dense white fumes are seen when it sublimates, and on further heating more strongly, then HCl and ammonia is formed, and then you can do a test for that. So
It already feels heated strongly though. I don't know why. Like,
Yeah. I think I wrote exactly what Ria wrote, where you say that on the cooler parts of the test tube, it will recombine and form dense white fumes.
So you're writing both, right? First it decomposes.
Yeah, we can write just both. Because they haven't specified temperature, how strongly they are heated.
Then question 3, Sana, you are the next.
Yeah, I didn't solve the paper. I'm just going over it with you guys now. So
like you want to do and then you can do like or else we can.
no, it's okay. I mean, I've just read it before. I'm just doing it orally.
Okay. Great.
So you all are saying it, right? Like
Okay. Yeah. Okay. So Swara, you have done this.
Yeah,
Okay.
I don't mind doing that.
Okay.
Question 3, acids when dissolved in water form a positive ion which is responsible for their acidic nature. Draw an electron dot diagram to show the formation of this ion and state the kind of bonding present in it. So that's hydronium ion. And then you show a water molecule plus H plus, which with the 2 lone pair of electrons. And then you show an hydrogen attached, and the entire thing gains a positive charge, and then H3O plus. The kind of bonding present is coordinate bonding. By the way, I had a question because we have water. Are we supposed to be mentioning covalent as well as coordinate?
Both.
Both, right?
Yeah.
Okay, then
You can, but I think it should be more coordinate. Like, I think that's what they are expecting.
I think coordinate.
Okay. Write the structural formula of isobutane. So that's 2-methyl propane or 2-methyl propane isobutane, like the T structure of propane. Then neopentane is 2,2-dimethyl propane with 2-methyl on either side of the middle element, forming the plus sign. Yeah.
Yeah, that's right.
Solve empirical formula of a hydrocarbon is CH2 if its empirical formula weight is equal to its vapor density. Calculate the molecular formula of the compound. Write a balanced chemical equation for the reaction that takes place when hydrogen is passed through it in the presence of a catalyst. So,
right?
Yeah, it's ethane.
C2H1.
C2.
And then it becomes ethane on reacting with hydrogen.
Yeah.
What was the catalyst used?
Nickel catalyst.
Nickel at 200 degrees Celsius. 300.
300.
Calculate the percentage of nitrogen in aluminium nitride.
Isn't it 34.14?
Yeah, 34.14%.
34.15%.
I got 34.15.
Rounded off from 3 decimals.
Yeah.
But it's still okay, right?
I guess. But Neelam says 3 decimal places now.
I think
34.15.
Yeah.
34.15 because it's 0.146, so 34.15.
I didn't take it to 3 decimals. I just stopped at 4.
It's 2800 by 119, right? Calculation.
No, it's 14 upon 41 into 100.
Oh my bad. Okay, sorry.
The formula is ALN now because both the valence is 3.
Tisha, you can do question 4.
Cool. Question. I didn't attempt question 4. Sorry.
Okay. Vatsal, you read.
Same, I didn't do this question.
Vedant.
Even I didn't.
I don't think anyone did it because it had like 5 give reasons and then it had.
I did question 4.
Oh.
Time pass. Okay, let's do it. Question 4a. Give reasons. Sulfuric acid can form 2 types of salts when it reacts with an alkali. Since it has 2 atoms of hydrogen in its molecule, depending on the concentration of the alkali used, it can either form a normal salt, which is sodium sulfate, or an acid salt, which is sodium hydrogen sulfate.
We have to mention due to its dibasic nature.
Dibasic acid.
Yeah, so same thing, not 2 atoms of hydrogen in molecule.
You can also say 2 replaceable sets of hydrogen. 2 replaceable sets of hydrogen.
Yeah. Second one, a covalent bond is formed only between non-metals. I don't know this one. With sharing, they mutually share. That's what I just don't.
I think they have a larger number of valence electrons, hence they usually accept electrons to become stable. But when combined with another non-metal, the acceptance or giving of electrons is not possible, due to which they end up sharing electrons and form covalent bonds.
I know that there's a small difference in their electronegativities. That's why they have to mutually share.
That's only for polar covalent, right? Not all covalent compounds have difference in electronegativity.
No, it's given a textbook that when there's a very large.
I think it can also be because of the reactivity. Like metals are usually reactive. That's why they can lose electrons. But with non-metals, they're only the halogens which are very reactive.
I would write what Swara said because metals have less valence electrons, hence they tend to lose electrons. So they don't want to mutually accept electrons. I mean, I frame it better, but yeah.
So we can say that because metals anyways have very few number of electrons, instead of sharing them, they can just give it away to attain stability, right?
Yeah, they don't want electrons, so they won't share them. Like they won't accept electrons.
Yeah. Okay, third one. Chlorine is more electronegative than chlorine. So as you go down the group, the atomic shell's number increases, and that dominates or increases in nuclear charge, making them more electropositive. That's why fluorine, which is above chlorine in the periodic table, is more electronegative. Fourth one. laboratory preparation of nitric acid and hydrogen chloride is carried out under controlled temperature. I think I need to write because otherwise it will form sodium sulfate and it will form sodium sulfate, which will form a hard crust. That answer.
Yeah, and also the glass thing you can add.
Glass may crack, nitrogen dioxide may decompose at high
You just wasted all that.
Yeah.
Yeah.
And fifth one, noble metals dissolve in aqua regia but are insoluble in all other acids. So noble metals are usually very non-reactive and thus cannot get dissolved. But for aqua regia, during its formation, a nascent chlorine is formed which attacks the noble metals and thus dissolves. B, answer the following questions. Write the equation of the reaction taking place. Okay, I don't know this question. I don't know the answer very well.
It should be anode, the OH one, like. Yeah.
OH minus 1 electron gives OH into 2. 2OH gives 2H2O. No, 2OH gives
4OH.
H2O and nascent oxygen.
Yeah, 4OH.
And then there is 4OH.
It's 4OH, no? Yeah.
4OH2.
Yeah, 4OH.
It's the same thing if you give nascent, so it's correct.
Yeah.
And then H plus 1 electron gives H plus H2.
Okay. Name the acid used in acidification, giving a reason. It's sulfuric acid because in the pure state, water has no ions and is a non-conductive electricity. Then third, electrolysis of water is termed as a catalysis reaction because the acidified sulfuric acid which is added, it only dissociates the ions so that they can get discharged of the electrode, but it does not really take part in the reaction to catalysis. And explain giving reasons that hydrolysis is a redox reaction. So at cathode, reduction takes place and anode oxidation takes place, and therefore simultaneously, so it is a redox reaction. And state a condition necessary for smooth electroplating on an article. A direct current should be used and a low current for a longer period of time, so there's a smooth and even deposition. And the electrolyte should contain ions of the substance to be electroplated. Yeah.
In the second one, like the acid one, like are they asking the reason for using sulfuric acid, or are they asking a reason for using an acid in the first place?
I think if you have to write specifically why sulfuric acid, you'll have to give a reason why nitric acid is not used, and it's given because it's explosive and decomposes or something, and it tampers with the reaction.
Yeah, so like I wrote that because they're asking why is that acid used?
Can't we write like the non-volatile thing?
You can write both.
I wrote that it's preferred over nitric acid because the nitrate radical might tend to interfere with the reaction.
So A, answer the following questions. Write 3 balance equations for purification of bauxite by Bayer's process. So the first equation is Al2O 3.2 H2O plus 2 NaOH at 150 to 200 degrees Celsius will give 2 NaAlO2 plus 3 H2O. Then the second equation is 2 NaAlO2 plus 2 H2O at 50 to 60 degrees Celsius will give AlOH thrice plus NaOH. Then the third equation is 2 AlOH thrice at 1100 degrees Celsius will give Al2O3 plus 3 H2O.
Is there any specific color for the precipitate of AlOH thrice? No, right? Like we don't have to specify that, no?
No, I don't think so. Because they're only asking for equations.
Yeah.
Name the process used to obtain aluminium Hall-Herold's process. Name the constituents of the electrolyte. The constituents of the electrolyte are fused alumina, which is Al2O3, cryolite, which is Na3, AlF6, and fluorspar, which is CaF2. With respect to the pH of water, state the pH range of A and B. The pH of A is anywhere from 0 to less than 7. The pH of B is more than 7 up to 14.
Yeah. Next one, differentiate between CuSO4 and CuNO3 twice on adding an acid like dilute sulfuric acid. NO2 gas is released, which is a reddish brown gas, and on the other side, SO2 gas is released, which turns lime water milky. And then next C2H6 and C2H4. On adding KMNO4 solution, it remains purple, and in the other one, it changes from purple to green, and then
we can use the bromine test also, right? In this decolorization of bromine water.
I use that too. Yeah. For ethane, the bromine brownish color is there, and then for ethene it gets discharged, right?
Wait, but I have a question.
Yeah.
Well, you said you're using H2SO4, but won't that form HNO3 instead of NO2 if it's concentrated?
I said dilute.
Okay.
Yeah, and the next one, dilute H2SO4 and concentrated H2SO4. So dilute H2SO4, it will not react with, it will react with BaCl2, and the other one will not react with BaCl2.
For the last one, can we write about reaction with carbohydrates, like the black spongy mass of carbon? We obtain it with concentrated H2SO4, but dilute H2SO4 does not have an effect on it.
Yeah, you can write any property of concentrated which is not in the dilute. So dehydrating agent, oxidizing agent, and non-volatile acid.
Okay, and even in the first one, we can use the BaCl test, right? Because BaSO4 it's a white precipitate, and BaNO3 is, I think, it's insoluble or something, or it's soluble in BaNO3.
BaNO3, yeah, the BaNO3
BaNO3 is soluble and BaSO4 is insoluble, right? And water.
Yeah.
Yeah, but
the
BaNO3 will be
last
formed
one-
in HNO3, na?
Yeah. But BaSO4 will be insoluble in HNO3 and BaNO3 will be soluble in like HCl and HNO3.
Can we react? No, Natasha, go on, sorry.
Instead of writing for concentrated and dilute sulfuric acid, I just wrote add magnesium, because then if a dilute hydrogen will be liberated, but because concentrated sulfuric acid does not act as an acid, hydrogen won't be liberated. Is that right?
Can we use heat as a reagent? Is it allowed?
For heat test, you're saying that?
No, like I've got a really stupid answer. Like we can heat both the acids because only concentrated sulfuric acid is non-volatile and dilute is volatile. So one will get volatilized.
We're talking about the first one, for CuSO4 and CuNO3 twice. Reacting with BaCl2, so we get BaSO4, which is a white precipitate, and BaNO3 is soluble, so no precipitate is obtained.
If you use PbNO3 the whole batch, you get the same result, no? The CuSO4 you get a white PPT and the CuNO3 doesn't react.
Yeah, either we can use it.
Guys, for the concentrated and dilute sulfuric, you all can do the acidic nature test for sulfuric, and you can do like Cu plus dilute H2SO4 will liberate hydrogen, whereas it will liberate sulfur dioxide with concentrated.
Yeah, there are many tests.
We can use any metal, right? Like zinc, copper, anything.
Yeah.
What was the answer of the first differentiate CuSO4 and CuNO3 type?
You reacted with BaCl2 or there's some different method too.
I
Tell
think
any
there's
now.
BaCl2 and then there's PbNO3 too.
Question 6 then.
Once again,
And
can you tell the
also,
first one?
in,
CuSO4 and CuNO3 dye.
in the first one of copper sulfate and copper nitrate, instead of writing nitrogen dioxide and sulfur dioxide release, I wrote just in the context of nitrogen dioxide. So reddish brown gas is released and reddish brown gas is not released. Is that still correct?
I think you need to mention a specific reaction for the other one too. Like a specific observation.
Yeah, I think it needs to match and then it will be right.
Can you tell the answer of that one? Like, what do you need to add?
I just wrote that when you add BaCl2 to CuSO4, it gives you a white precipitate of BaSO4, which is insoluble in HNO3 and HCl. But when you do it with copper nitrate, it will give you a white precipitate of BaNO3, which is soluble, or you can even say dissolves in dilute HNO3 or HCl.
Okay, thank you.
Vedant, you did question 6, so you can do that.
Well, question 7.
Okay. Question 6, anyone wants to do?
I can do question.
Yeah.
Okay, for the first one, I used AF as HCl gas. NaHCO3 plus HCl gives you NaCl plus H2O plus CO2. And for B, I use concentrated H2SO4 because below 200 degrees Celsius or about 200 degrees Celsius, you get HCl. And for the second question, A was HCl gas moist. If you reacted with NH3, you get NH4Cl. And B, I used chlorine gas. When you use excess of ammonia, you get NH4Cl plus N2. And C is oxygen gas. When you react NH3 with oxygen, you get nitrogen. It's the greenish.
Can we use PbO or CuO? That will also give N2.
They're gases. They are
Gases.
Yeah. And also, Ria, what did you write for the the NaCl one? What did you write there?
Sorry, which the first one? I used
Yeah.
HCl. It's the preparation of HCl ka reaction. You use NaCl and concentrate.
But sulfuric acid is an acid, right? And they specified gas.
Yeah.
So should we use like a volatile acid, because you need an acid, right, for this reaction, and you cannot use.
No, I think what they meant is that ABC only for the second part, and for first part you can use anything. Could be that way.
Yeah, because they mentioned C.
Yeah, there's. I don't think there is any other way. What's
Could
the other
someone
way?
repeat the answers for A, 1 and 2? I mean, only the first part, like A and B.
The first one A is HCl, B is H2SO4. The second one A is HCl, B is chlorine, C is oxygen.
Cool, thanks.
Wait, but if you're gonna use chlorine for getting NH4Cl again, what will you use to get nitrogen?
You can use for the C part. You can also use oxygen, like burning of ammonia and oxygen to get nitrogen.
The reduction one. Yeah.
Ria, the B part.
Yeah, sorry. Yeah. Lone pair of electrons. A pair of electrons present in a covalent bond which does not participate in the bonding. Electrolyte dissociation, the process by which an ionic compound in the molten or aqueous solution state dissociates into three ions by the passage of an electric current through it. Empirical formula is the formula which shows the simplest whole number ratio between the atoms of the elements in the compound. Then differentiation between MgCl2 and CCl4, one in solubility. MgCl2 is soluble in polar inorganic solvents like water but insoluble in organic solvents, and CCl4 is insoluble in polar inorganic solvents like water but soluble in organic solvents. MgCl2 conducts electricity in the molten or aqueous solution state but not in the solid state, and CCl4 does not conduct electricity.
Yeah. Cool.
This was in the electrovalent versus covalent table, no?
The adds in the covalent bonding structure. The big table.
What definition do you give for empirical formula?
It is a formula which shows the simplest whole number ratio between the atoms of the elements in the compound.
Say louder.
The simplest whole number ratio between the atoms of the elements in the compound.
Between the what?
Atoms.
Aren't you all in the same house?
Look, he's in the other room. I don't want to go. Say
Oh my god.
Say it again.
I can argue afterwards. Yeah. Vedant question 7.
Okay, next question.
Yeah. Identify the following salts. The salt solution A gives a pale green precipitate with NaOH solution and a white precipitate with BaCl2 solution, which is insoluble in mineral acids. Ferrous sulfate. Then the second, the salt solution B, which does not react with
Vedant, we're doing question 7.
Yeah.
Yeah. There's one more question before that now. MgCl2 and CCl4 differentiate.
That's already answered.
So MgCl2 is soluble in water and conducts electricity, and CCl4 is not. Go on.
The second subpart, the salt solution B, which does not react with ammonium hydroxide solution but gives out brisk effervescence with dilute HCl, and the gas evolved turns lime water milky and shows no effect on acidified potassium dichromate solution, calcium carbonate. Third one, an orange crystalline salt C decomposes with sparks on heating and forms green fluffy powder, ammonium dichromate. A bicrystalline salt D decapitates on heating and forms yellow residue. The salt solution, when treated with acidified iron 2 sulfate solution, forms a brown ring, lead nitrate. Write balanced chemical equations.
Mom, how do you know it's ammonium dichromate?
Exactly, it can be potassium dichromate also.
Yeah, because I wrote potassium
Even I wrote potassium dichromate.
Actually, I didn't know this one, so I was like searching on Google which salts are orange and crystalline, and then ammonium dichromate popped up. But it's a pretty tough question. Like, we don't have this anywhere.
I haven't really given any test for the cation. I mean,
Potassium dichromate is orange, and what is ammonium dichromate?
that is also orange.
I think either will be accepted.
Exactly, but they haven't given any test for the cation. I mean, we know all dichromates are orange and nothing.
Yeah, exactly.
Heating, they become green and stuff.
Also, what was salt B? Can someone say?
Calcium carbonate.
Calcium carbonate.
Yeah, thanks.
Wait, but don't potassium salts don't decompose? Isn't that there in some chapter? Potassium and sodium salts don't decompose.
Because they're higher on that list.
Yeah, exactly, high on the reactivity. So then it should be ammonium dichromate.
So it'll never decompose like potassium even at high temperatures?
Yeah, I think we did that.
The internet also says only ammonium dichromate. It doesn't say potassium.
Okay.
Potassium has the same observation though. I just even that forms a green fluffy powder.
Then I think either will be accepted.
Green fluffy powder is chromium oxide, no?
Yeah, chromic oxide.
That's the rest.
Vedant.
I think we should write ammonium dichromate because we've done this test with ammonium dichromate in school last year. So most probably they'll prefer ammonium instead of potassium.
I think it's ammonium only.
Yeah, mostly.
Write balanced chemical equations for the following. Burning of ethene in air, C2H4 plus 3O2 gives 2CO2 plus 2H2O. Heating of silver nitrate in a dry test tube, 2AgNO3 gives 2Ag plus 2NO2 plus O2. Heating of carbon with concentrated nitric acid, C plus 4HNO3 gives CO2 plus 4NO2 plus 2H2O. Reaction of manganese 4 oxide with concentrated HCl. MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Write 2 chemical tests to identify the ions present in ammonia solution. First test blends white fumes when rod dipped in HCl is brought near it. I can get a second test.
I don't know if it's reacted with copper sulfate. Like if the solution is reacted with copper sulfate, a failure precipitate dissolves in excess.
Yeah. What did you write for like testing the presence of ammonia ions? Do you have to do that?
HCl gas, you get a white solid.
Yeah, I did that.
And there's a Nestler's reagent also. Colorless to pale brown.
Yeah, so it turns brown, right? Naturally.
Yeah, pale brown.
I think.
Also, we need to mention that it heats, right? Like you have to heat the ammonia solution and then the gas will be formed.
Yeah, so heating it with Nestler's reagent will give the reddish brown.
Does ammonia have any particular flame color or anything?
I don't think it gives.
It has a greenish yellow flame.
In air, right? Both the greenish yellow flame in air.
Copper.
Guys, your turn to know that what was I going to say? Yeah, in excess of NH4OH, it forms an aqueous solution. That's first test. And dense white fumes with concentrated HCl, second test.